Hi, thanks for joining us today. We're going to continue our discussion of the calculus of exponential functions in lesson 7-2 with integrating exponential functions. So, as we talked about yesterday, the derivative of e to the x is e to the x. So that means the integral of e to the x is e to the x. The antiderivative of e to the x is e to the x. Because the derivative of a to the x had that weird hook on natural log a, we sort of have to divide by it when we go backwards. Okay? We'll just always remember to divide by natural log a when we're going backwards. And again, you don't have to memorize these two forms. What you have to memorize is the chain rule versions, or in this case, the reverse chain rule versions. So we're still making sure that we have the derivative of the exponent to hook off, the derivative of the inside guy to hook off, just like we would hook on when we differentiated. This is really not that bad. It sounds more confusing than it is, but you've been doing it for 2 chapters now. So we look at this, and for sure, you are going to be scared. You are going to look at this and say, I don't know how to do it, skip. All we're trying to do in this chapter is to fight that urge, or at least learn to fight that urge. So I would say, oh look, there's the inside of this exponential function. What's the derivative of x squared minus 1? It's 2x. And wouldn't you know it, based on everything we learned in chapter 5 and practice in chapter 6, I can turn this into 2x. All I have to do is pay for it with a 1/2 on the outside. Again, these are tied intrinsically, so I'll have them in the same color. Shoot. 2x. So this becomes my hook off, and now I can take the antiderivative using the same rule we had over here. So the antiderivative, as long as the hook off's there, we have the same exact thing, but we divide by natural log. So we'll keep this part the same exact thing, but instead of multiplying when we're deriving, we'll divide. We also have to keep in mind the 1/2 on the outside. And obviously this is being evaluated from 0 to 1/2. There's no plus c because it's definite integration. You might want to go back and rewatch that. This is probably one of the more confusing ones we do. But that's what we're doing. We're going to look at the exponent. We're going to get the hook off based on the exponent, just like we got hook-ons based on the exponent in the last video. After we get the hook off, we keep the rest the same. We divide by the log of the base, and we evaluate. So that'd be only probably 2 points, 2 to 3 out of 4, or 2 out of 3. 1/2, plug in the top down first. 4 to the 1/2 squared is 1/4 minus 1. Minus 1/2. Even on test 6, people are still assuming that when you plug in 0, you get 0. On test 6, I basically saw people write this and then still think this was 0. It's not 0, folks. 4 to the negative 1 power is not 0. Leave it here. That's fine. 100%. You write 0 here, you're not getting 100%. I don't know why that popped up. Frustration rising. Okay. Next. So we have e to the 2 over x over this ugly thing. Again, in the foreseeable future, the newest thing in your life is the exponential. So you should be drawn to that. All right? And now, more specifically, you should be thinking about 2 over x. That's the exponent of the exponential. That's the inside. What's the derivative of the inside? And if it helps you, write it out. What's the derivative of 2 over x? Do you have something? Well, that would be the derivative of 2x to the negative 1. That would be negative 2, x to the negative 2. Whoa, sorry. Big mistake. Just be this. No more derivative symbol. That's a student mistake right there. I've seen that happen to many students. Careful, careful. I did it. It means you're definitely going to do it. So, do I see a way to get this in here? Yes. I'm going to have to be creative, but I definitely notice this x squared in the bottom can be turned into x to the negative 2. So I'm going to rewrite this integral. E to the 2 over x I'll ship the 3 out. It's 1/3 because that was on the bottom, so it's 1/3. I'll get my x to be a negative 2. And we'll have the dx, which was always there. So now I don't want it to say just x to the negative 2. I want it to say negative 2x to the negative 2. So I need to multiply the inside by negative 2. This one. And that'll be my hook off. That whole thing was the hook off right there. You needed to say that, and now we have it. But to pay for that, we have to do a 1 over negative 2 times. Please be very careful. This is a hard one. You have to be willing to rearrange the integral to get what you need. You needed it to say negative 2x to the negative 2. We had a way to get x to the negative 2, so I killed this other constant. I didn't like it very much. There's other ways to get the negative 2 there. And I brought the power up. And when I move powers, the sign of the power changes. So that hooks off. Negative 1/2 times 1/3 is 1/6. I don't want to use purple. It's right next to the other purple. Negative 1/6 parentheses. That guy stays the same. You could divide by the natural log of e, but the natural log of e is just 1. So we're just done. So as complicated as that is, that's it. We don't have to write divide by natural log e. If you write divide by natural log e, that's fine. Unless it says the word simplify. Plus c because it's indefinite. Done. I know that feels weird, but that's just the rule for e. For e, nothing happens. It's the same. last. I want to shrink everything a bit. This last guy is the hardest one. We see a lot of exponentials. There's a lot of stuff going on here. Once you train yourself, you might be able to notice something else is a bigger deal. Something else needs to be dealt with first. Something else is harder to deal with. 3, 2, 1. The thing that's hardest to think about, the thing that's hardest to work with here is actually the power. Okay, so we're going to rewrite. We're going to have this power on top times the original numerator. This is a move that's somewhat useful some of the time. I would not just do this all the time. I do not always move stuff to the top. It works here and here. It does not always work. Careful about that. So now we're thinking, though, that I have a group to a power. I have a group to a power. I have this power function, and I have the inside. What's the derivative of e to the x plus e to the negative x? 3, 2, 1. Did you think about it? I'll wait here. You can pause the video. The derivative of e to the x is e to the x. The derivative of positive e to the negative x is e to the negative x. You keep it the same, and then you multiply by the derivative of the power. What's the derivative of negative x? It's -1. So to write this out, which you shouldn't have to, if you really did all the practice, you should have. It stays the same. And then multiply by the derivative of the power. So this is the hook-off. This is the derivative of the inside here. That whole expression is the derivative of the inside of this one. So this is just reverse power rule. That's all that's going on here. Isn't that something? So we'll keep the inside the same. Add 1 to the power. Divide by the new power. Plus c. Because it's indefinite. There's no bounds. And that's it. Obviously, there's a lot more to practice here. Please try out problems on page 139. Okay? Good luck. Have fun. Feel free to talk to me in person. Email me with any questions. You guys have a great day. Have a great night. I will talk to you later.